Good evening, everyone. We're just giving folks a few minutes to join before we get started as people are clicking on and getting their cameras set up. So just bear with us. If you've just joined us, we're just giving it a couple more minutes to let people log in, and then we'll get started. Okay, well, it seems like we're getting people logged on and joining us tonight. I even see in the participant list some people who've been connected with Eastern for a long time, so welcome. I think it's great to see some of you joining us and really see what happened to maybe a facility that was created when you were around here. So thanks for coming. For those of you I don't know, my name is Tim Seydel. I'm the Vice President for University Advancement here at Eastern. This new series of virtual events we created really is aiming to keep alumni and friends like you connected with the university community, even when we're at a distance, and maybe because we're at a distance. So this allows us to reach out and connect with folks a lot further away than just Eastern Oregon. Our agenda tonight is an update with President Insko, focused on the College of Science, Technology, Math, and Health Sciences, including a live tour of Badgley Hall, with an EOU student, and also we have a special guest lined up there too. Couple points for you. If you have a question, you can put it if you're on a computer on Zoom, down at the bottom, there should be a Q&A icon. You can click on that and on that Zoom option bar, and we'll answer them along the way and afterwards too. So we'll be gathering those up and sorting them, and then providing answers along the way and after our meeting as well. So I think with that, to get started, I'm going to introduce President Insko. He can provide an update for us, and we'll take it from there. So Tom.
Well, welcome everyone. This is our second one of these. It's great to be able to do this, and I just want to start off by thanking those of you that are participating and sharing with alumni and folks, and also our AV folks that allow us to do this. We're in Badgley Hall, or at least some of us are, and our tour is going to be in Badgley Hall. And my recollection of Badgley Hall when I was a student here at EOU, I attended Eastern from '89 to '94, graduated with a degree in math. so part of this college. I also got a degree in business, but I spent a fair amount of time in Badgley Hall. At that time, some of you may remember, it looked very different, and you probably all remember the fountains in front that some of us students every year would find a way to sneak in and dump in laundry detergent so that we had a nice bubble bath going on at some point, or various types of things like that. So it's great if any of you haven't been on campus for a period of time to have this facility that we have today, which is a massive upgrade from when I was a student here back in the early 90s. But what hasn't changed, and what you'll get a little feel for, is the experience that I had as a student here, and it remains consistent in terms of our commitment to providing a authentic, or an experience where you develop authentic relationships with your faculty and staff, and that's continued. When I was a math major here, I valued so much my relationship with my faculty at that time, and being able to talk with them outside of class, being able to have dinner with them when I was of age to share a beer with them. And the reason why I was successful in getting a math degree is because I had access to my faculty and such. And when I came to Eastern back in 2015, we were going through sustainability. We were in a challenging dynamic, and in fact, we were cutting things like computer science degrees, and we quickly changed direction in that regard. We brought our computer science degree back. We've also added to it with an online degree. We've also, we're initiating cybersecurity degree, a degree in IT management, and we'll spend a little bit of time, I won't go into it, but we have faculty that'll talk about our sustainable rural systems degree as well. And what we've really been committed to is developing degrees that are relevant to our region, that really help build pathways for our students within our region, provide that access to an education that every person should have available, but in degree programs that they can then go out and secure careers in, or if they want to continue on, pursue graduate programs. And the fact that students get to work so closely with faculty, often doing research in their undergrad time, really prepares them for that next step in grad school as well. And so we're excited to share some of that with you today. We've also been investing in the infrastructure here, and we're happy to have the university in a position where we can do that investment, buy the equipment that we need. I wouldn't suggest I could even pronounce some of the equipment that our faculty purchased to create the robust academic experience for our students, but we have been investing in those gizmos, let me call it that. And it's part of the reason why we have things like the Science Journal that recently received a first place award with special merit, an additional nod for outstanding theme from the American Scholastic Press Association. You know, these are things that don't commonly happen in an institution, a regional institution like Eastern, but because of the dedicated faculty and staff that we have and the great students that we attract here, we're able to do that. And we're going to talk a little bit about our chemistry club. I was part of the math club when I was here. We got to compete nationally. And I know our math club consistently places nationally as well. So we're just blessed with high caliber students, high caliber faculty, and it's exciting to spend a little bit of time sharing with you the College of STEM Health Sciences and to focus on Badgley Hall. So with that, what I'd like to do is move it over to the actual tour. And we have EOU Ambassador Emma Finley on hand to tour us around. So Emma, take it away.
Thank you, Tom. My name is Emma Finley. I am currently a junior here at Eastern Oregon, and my major is elementary education. Welcome to Badgley Hall. This hall has the College of STEM. So the classes here are science, technology, mathematics, and health sciences. If you haven't heard of this college, it's because EOU split from 3 to 4 colleges back in 2017. And so now the College of Art and the College of Science are split. Here with me today is Professor Colby Heidemann. He is a chemistry professor and the advisor for the chemistry club. He is going to be showing us around.
Hi, and welcome to Badgley Hall.
Tell us about the equipment in here. What are some things your colleagues have been working on?
So this is Dr. Joe Corsini. He's currently sitting at our scanning electron microscope. And in essence, this is similar to a normal microscope you've probably heard of before. The difference is that instead of using light to image objects, it instead uses electrons. And the benefit of this is you're able to see things that are much, much smaller compared to what you can visualize with a normal optical microscope.
So you want me to
Sure, go ahead, Joe.
carry on? Okay, well, so here we have a sample that I collected from Hot Lake, the local hot springs. And I'm trying to find some thermotolerant diatoms. So this would be diatoms that could kind of live their life out in hotter waters than we normally think of as normal. And so anyways, these diatoms, you can see some of them here. I have this magnification at about 7,500. The highest magnification you can go with a light microscope is, you know, kind of for normal light microscopy and 1,000 times magnification range. They have some that will go up, pushing 2,000x. But with the electron microscope, see here, we have 7,500 here, and we can easily double that right here. It's just a flick of the wrist. And let's see if I can get it focused now. I'm going to try to focus on this one right here. So I'm going to try to bring this into the middle of the screen. And there we go. It's coming in. It's coming in. Anyways, you can, with this machine, you can see how you can, you kind of look at the entire organism. So these organisms are super cool because they photosynthesize, so they absorb sunlight, carbon dioxide from the air, and then they produce all the body parts from that. And in terms of their body parts, this shell you see is actually a glass shell. It's like the glass in your wine bottle or whatever. And they use proteins that they synthesize themselves to sort of nucleate the glass and form these intricate glass cell walls. And they protect themselves with the glass cell wall, and so they photosynthesize. So they're doing a lot of stuff that plants do for us too.
Yeah, so that's super cool. One thing.
Go ahead.
Oh no, I was just gonna say one thing that's also really cool with this instrument is it's super versatile. So it's something that's used in biology research, and chemistry can also make use of this type of instrument to just look at. And one thing that's really nice is everything's very visual. So even if you don't necessarily understand the instrument, you can still just see what's going on. Anyways, thank you, Joe.
Yeah,
Thank you.
you bet.
How have some of your courses changed during COVID-19, and how have some of them stayed the same?
So one thing that's been super awesome being a faculty member here at EOU is that we've been able to keep the face-to-face interactions with students going despite the pandemic, taking appropriate safety measures. And so especially in the most critical areas, we're still able to meet face-to-face with students. So for example, for our labs, we're able to meet in person for our lab courses. We have had to make some accommodations. We've decreased the cap sizes. We've created cohort groups, which also helps us accommodate when people need to go into quarantine or things like that. But we've been fortunate that, especially compared to most institutions, our students have been able to get a lot of face-to-face interaction. But at the same time, we've been able to meet the needs of the students that maybe aren't able to make it in a normal classroom setting. So one great thing about being a small institution is it allows us to be flexible. Some other things that we've done is we've switched from, or we've set the classes up to accommodate the nature of the class. So we have everything from classes that are completely in person to some that are hybrid, where we meet some in person and some online. And then in some cases, we have remote classes where we're still interacting in real time with our students, but we're doing that remotely.
This building was renovated in 2005. Right behind me is a sculpture of 3 water molecules. There's also psychology and math labs downstairs,
As well as computer science.
as well as computer science. What are some courses that you're teaching this term?
So this quarter, I'm very general chemistry heavy. So I teach a Chemistry 205 course, which is Eastern Oregon's general chemistry, the second quarter, as well as a lab course that accompanies that. And then I'm also teaching a research course this quarter.
If you have any questions, please type them into the Q&A box and we'll answer some. So Eastern Oregon is partnered with 2 other Oregon universities. One of them is OSU. We have our agricultural sciences program through them. There's also crop and soil faculty use the research center in Union. Why did you become a chemistry professor here at Eastern?
So that is quite a long road that started actually at an institution that is quite similar to Eastern Oregon University. So I did my undergraduate work at a small regional state university, Southern Utah University. And I really enjoyed the personal attention that I received there, a lot of the same traits that we prize here at Eastern. But one thing that was kind of unique for me is that I went on to graduate school in chemistry at the University of Oregon. And at first I thought, there's no way I want to teach. I'm going to go into industry and make good money. Most of the people from my research lab went to work for places like Intel. But I was graduating around 2009 was when I was originally planning to defend my dissertation, and the job market was terrible. And so I talked to my PhD advisor and we decided, all right, I'll just stay on another year, add a little more to my thesis. And during that year, I started doing a lot of work, mentoring undergraduates, working with them on research, and suddenly realized I love doing this. And that's when I realized I wanted to switch from going into industry and instead find a job at a small regional institution like EOU. And it's been a great place to work.
Here we are at the Oregon Department of Fish and Wildlife. This government agency partners with a lot of the EOU programs, and they're able to go out and learn some stuff with this agency. So the Eastern Oregon Foundation helps sponsor the Science Journal. How does the Science Journal help the students here?
So the Science Journal is a great resource for our students. throughout the entire process of publishing the journal. For example, we have student editors that gain leadership experience as well as editing experience process. In addition, all of the cover art is produced through student work, and so they get experience with graphic design. And then also, it gives a great opportunity for our undergraduate students to get experience with writing journal articles. I still remember my first time as a graduate student publishing or preparing a paper for publication. And that was a daunting process. And so just giving them the opportunity to gain that experience at the undergraduate level is a great opportunity.
All right, students can major in pre-nursing here at Eastern Oregon, and they can smoothly transfer to the OHSU nursing program. This program supports rural hospitals and offers ongoing education for healthcare workers. What challenges face the students right now, and how can alumni get involved?
So right now is definitely a very difficult time for students attending a university. One of the challenges is just financial. Most of our, well, or at least a large portion of our students work jobs or would like to work jobs to make money, and that's definitely more difficult right now. And so, you know, just having scholarships available to them is a really important part for the students. Additionally, our clubs right now, they're continuing to try to be active, but it's much more challenging due to the virtual format that a lot of things have to take place in. But you know, one thing that we still try to do is continue to do outreach to the community where we can. Just as an example of that, this year, well, every year the faculty in Badgley put on a Girls in Science program. And this year, we weren't able to do that in person, but we decided we wanted to go ahead and do that. We wanted to go ahead and do that virtually. And so partnering with a group called EOU, we were able to send out supplies to the participants and still hold this event for the region.
All right, so this is our animal museum where biology students get hands-on experience with pelts, feathers, bones, and other animal remains. Local elementary schools and scout troops also get to come here and visit the museum and explore scientific concepts. Why is STEM education important in rural communities?
So I think one thing that this pandemic has really highlighted is the importance of science and technology. And that ranges everywhere from the importance of rural healthcare, both mental as well as traditional doctors, and programs in Badgley from biology, chemistry, psychology really contribute to that. In addition, as we've been pushed more and more remote, technology has become an increasingly important aspect of our rural lives. And so our programs in computer science are extremely important for helping students contribute to the area being able to participate in this digital world.
So what is this equipment and how is it used?
So in here we have our nuclear magnetic resonance spectrometer. I think that's one of those words Tom was referring to in the introduction that he's not comfortable pronouncing. But essentially, this is a very similar instrument to what's found in a lot of hospitals that you know as an MRI. In both cases, it uses very, very strong magnets to play with the nuclear spins of atoms. Okay, and then it probes those using radio waves. The only difference is in a hospital setting, it does that in order to image things, whereas in here we use it in order to help us to figure out the structure of molecules and how atoms in molecules are connected. One great thing about Eastern is that our students not only are involved in research, but they are the ones doing the research. They're the ones that are running the instruments. So right now, this instrument's running a sample for Dr. Kelly. And so he does extraction of natural products and then tries to figure out the structures. So you get all these lines that show up, and the positions of those lines, the splitting of the lines, and the intensity of the lines all give you information about the structure, how things are connected, and how many different groups are present in your compound. And it goes through a lot of liquid nitrogen.
What is some research that you're working on right now?
So my research focuses on a class of materials that are referred to as thermoelectric materials, which are materials that can either pump heat if you put an electrical current through them, or you can also use them in the opposite fashion, where if you have one side of the material that's hot and the other side that's cold, then it can generate electricity.
Thank you so much, Colby. Are there any questions, Tim?
I have a really interesting one, and I don't know if Colby or you would know this. One of the questions is how many square feet are in the building and how many stories? I don't know. We might even have to tap our dean for this. He might have an idea for it. I know there's 3 stories to the facility. How many square feet? I am trying to remember exactly how many. I know we added quite a bit of it to the old facility, and I want to say it's pretty high. Dean Peter Geisiger, do you have any idea?
Not really. I have to do a wild guess too.
So yeah, I can look that up and see. Got a couple other questions. This one's really for Colby. Is that kind of like how on earth? The question is how on earth can you do chemistry remotely? Are you teaching it remotely for the student is somewhere else? How do you do you send them samples, etc.?
So that's one great thing is you're right, chemistry is really challenging to do remotely, especially the lab part. And so that's why we're really fortunate that we've at least had some level of in-person classes for our chemistry courses. So we're able to meet in person for our labs, and they're able to come into campus, work with the instrumentation, work with the different apparatuses in order to really get the practical skills that are needed for a chemistry major or sciences in general. This is also for our biology students as well. So we're able to get them into the lab and get that practical experience.
Another question is, have you had to be very innovative and come up with something, something crazy? We heard early on, particularly during COVID, it's like some of our art faculty were literally telling students, if you can't get the formal clay, grab some Play-Doh and let's even work with something like that. If you had to do anything along those lines.
Yes, absolutely. So just from personal experience, I also teach a Science 101 course, so just a general science course that's more for general education purposes. And for that one was purely remote, but I like to still have a hands-on component for the class. I like them to do experiments, really apply science. And so I just had to think at the beginning of the quarter, what are experiments they can do with materials that they have in their dorms, and what kind of science can we do with those materials? Then we've also been really creative in terms of our scheduling. Like I said, one challenge is, we can have a student that's out for 10 days due to quarantine or whatever, and so they are going to miss their lab. So how can we set our schedule up so they can still get in and do the lab experiment and still be successful in the class? And so we've tried. In fact, I really feel like we've been very successful. Our students have been able to, for the most part, do a lot of different lab experiments, get hands-on experience, and still not have to worry too much about if they do have to quarantine or isolate for a time.
I have another one because where you're standing has caught people's attention. Is that a Science of Beer poster behind you, Colby?
It is indeed a Science of Beer poster. So Dr. Cavanato, who is on sabbatical this year, is an analytical chemist. And so she does a significant amount of research, and she has done in the past, revolving around components that are present in beer.
That's pretty good. Have you had any other similar, pretty interesting student projects like that? Or are there some strange ones you might recall?
Well, you know, one that's the students really like is a research project that's ongoing for our general chemistry lab, and that is a Lab Marsh research project where we start out the quarter by taking a field trip with the students out to Lab Marsh, where they collect water samples. And then the rest of the quarter, their project is to characterize what is in those water samples. And that's extremely relevant for the Valley, for the community. And so, and for the students, just learning practical applications of chemistry and how it interacts with the everyday world around them. So they'll do all kinds of different experiments so they can figure out things dissolved in the water, amounts of nitrates, amounts of phosphates present, just so that we can know what's present in this area of the Valley.
So some hands-on. I did get an answer thanks to some of our great staff members. If you want the actual square feet of this building, if you had a number in your head, think about this. It's 99,878 square feet. So quite a big facility. If you were here since it was built, the original component was built in '64. So if you here went from '64 up until really about 2004 when we made this massive addition, you can see, and I think that's kind of what was in my head. I wanted to say, I think we added something like 60,000 square feet to the facility. So the second wing, the west wing, if you will, is quite a bit larger than the old east wing with its radiator. I will tell some of the older, more retired faculty, people like Dr. Richard Hermans and others, had told me that the building was actually designed to have an extension already onto it on that west side that was planned for a phase 2. And he said, "Congratulations, it just took you 40 years to do it." So if you know Dr. Hermans, you know that he would be giving us a hard time about that. So we finally got around to him. I told him it took a little while, but we made it happen. I did have another question for you, Colby. With that equipment that's in the Science Center, are there other folks using it besides students and faculty at Eastern?
So the students and faculty are definitely the primary users, but we do have collaborations sometimes. So just one example, I'm also a peer learning community leader for a program called Eastern Promise, where we work with high schools to offer dual credit through EOU. And one thing I've done in the past, I haven't been able to do it this year, but I'll actually bring students from the regional high schools here to EOU so that they're able to participate in lab activities that they wouldn't be able to do at their local high schools with the equipment they have available to them there.
And are you aware of if there's any research? I think maybe in the past we've had some people doing postdoc work and other things where they have been able to tap into our facilities that this is really unparalleled equipment, as I understand it, from a lot of other places in this entire region.
Yeah, so in addition, we also mainly we'll collaborate with like local community colleges. We definitely do have cutting edge research for an institution that within the sciences is primarily undergraduate. In addition, though, our faculty also do collaborate with other institutions. I've had collaborations running with University of Oregon, Dr. Andrews. Dr. Andrew has some with OHSU. We've had collaborations with PNNL. And so, yeah, we're definitely very much integrated into the broader scientific community. And sorry, I'm most familiar with the chemistry faculty and their research, and I'm sure that the other faculty are also similarly involved.
Awesome. Thank you so much. Thank you so much for that. I have another question regarding our Sustainable Rural Systems program. Shannon, I was wondering how you can tell us how it's going with that new program. It just started this fall, so how are things going?
Hi, yeah, thank you. My name is Shannon Donovan, and I am a faculty member in Sustainable Rural Systems. It is a new program, and I'm also a new faculty member, so everything's sort of shiny and new for us here. Things are going really well. We're off to a good start. The students seem pretty excited and interested, as does the community. I've had a chance to talk with a lot of different folks in the community about different project ideas. And we're hoping the project will just continue to grow.
What kind of programs? We're going to really quick, just for added context for those that are watching. The Sustainable Rural Systems degree was really launched in a different way than most degrees start. We reached out to the external community and basically invited them to come and inform how we design this degree. So the external community was working with our faculty as they developed the curriculum, our deans, of course. So that was very relevant to fulfill the needs of our communities here in rural Eastern Oregon. As most people know, it's a project-based degree, and so it really relies on those partnerships so that our students can get the experiential learning that we consider as critical to any higher education degree, but what we're committed to providing every student at EOU. So it's a signature degree for Eastern and what is now Oregon's Rural University. So we're excited to have Shannon really launching this and leading this on behalf of the college, and Dean Geisinger for his leadership in making this happen.
Yeah, and I could speak for just a moment to the some of the projects if you're interested. We're just getting things off the ground. Of course, starting a new program that is project-based during a pandemic has its challenges, and I think we're trying to figure out ways to overcome those. We just today had a meeting with the folks from the Baker Technical Institute who are our partners on kind of figuring out how we can forge ahead with the collaboration and develop more brownfields projects. So a brownfield is an area that is contaminated or suspected to have contamination and has the possibility and is vacant or underutilized and has the possibility of being changed into something useful. Kind of surprisingly, I think, and shockingly, LeGrand has thought to have amongst the highest numbers of brownfields in the state of Oregon. So the Environmental Protection Agency is very interested in helping Union County, LeGrand, Baker in taking some of these underutilized spaces and turning them into really great things. So we have a wonderful opportunity to come in at on the ground floor here in LeGrand. The city is pretty excited about it. In Baker, they are working on the old central school. And so our students are going to start doing some work down there. Everything so far has been remote. Like we've been working on various different things through grant writing and guest speakers and learning about things online and videos. And I think in the spring, we're going to have a chance to do some more hands-on work that's field trip based. And so that's the central school will be kind of where we start. And then we're going to be moving up here into LeGrand and doing a community assessment and trying to work with the community around prioritization and seeing how we can kind of fill a need and bridge some gaps between the university and the town and make something that's mutually beneficial.
If I may add something, one of those instruments with the unspeakable name, gas chromatograph mass spectrometer, that we are about to purchase, the version of this instrument is ideal for measuring organic pollutants in soil. So that's very relevant method and technique, you know, to look at brownfields where there's soil involved to really extract what's in there and determine what's in there. So our students can learn these techniques at state-of-the-art instrumentation right here in the lab with real samples.
Peter, to follow up on that, are there other new programs on the horizon for your college?
Oh yeah, we are really very excited about. It's been hectic development. First of all, is starting in fall our new cybersecurity degree that Tom mentioned, and that degree goes really back also to community involvement. In the community colleges asked us, you know, to have a pathway for our students to a bachelor's degree. Mount Hood Community College, Blue Mountain Community College helped that. We actually talked to their computer science industry advisory board, and they impressed on us the cybersecurity needs of the region, of small businesses here, of small school districts, of small government agencies where there maybe is only one IT professional needs to handle all the data science, the data protection needs that they need to have. So forward a little bit, we just had a great stroke of luck, but we learned that in Cove, an industry professional in cybersecurity was actually working for Symantec, a giant in computer and information security, working remotely as a team leader in offensive security. So he really is what he calls an ethical hacker. And he is starting to teach classes for us, and he designed our cybersecurity just for those needs that he sees that small businesses have. So our degree is really focused on not on the high-end cyber crime and international money laundering, you name it, but on the everyday data security needs of small companies, small businesses that we find everywhere. So we're really thrilled he's going to stay on. He's going to keep working in the industry. So we always know firsthand what is happening in that field. Daily, every day, new threats emerge, and we have the pulse of the field, and we can bring that right to our students. We're about to hire our first faculty member, the lead faculty member also. So that really has been a great effort on behalf of many people who contributed to that. Similarly, we are working on a data analytics degree, data science, big data sets, and extracting from big data sets relevant information is really critical and used in many areas from agriculture, healthcare analytics, economic data. So the our math faculty and our computer science faculty got together and came up with a degree that rests on those pillars and then culminates in specific advanced statistical courses. And a key feature is a one-year capstone project where we want students really to go in an application area, whether this working it with agricultural scientists from OSU looking at data on farming and ranching, or whether it's working for the local hospital, you know, looking at healthcare data, working for economic development district. So really get that in-depth at the job experience for that. And we're also in the process of recruiting our faculty member for that. And then finally, just a little side note, we have a health and human performance degree, and they have a concentration called outdoor recreation programming. It's just really geared about planning for expeditions, doing them safely, and we're also connected to mental and physical health aspects in the outdoor environment. Of course, that was only on campus here, making use of our great natural environment. But the faculty and this department said, well, we should find a way to bring this to our online student population. And how do you do that? Well, we're changing the format of the degree to have a summer low residency period, where online students would do all the work, all the planning work online courses, but then they would come and join the on-campus students for a 2-week residency in the summer where they put this all in practice, and then they get to experience our great local environment. That was a great thought, great process of the faculty, innovative to bring the benefits of our programs in our region to a larger number of students.
Thanks, Peter. I'm sure that maybe if there's some expeditions coming up to, you know, Kilimanjaro or somewhere that you could get some of these alumni attending tonight who would want to go along with it.
That sounds good.
I do have a question that maybe President Insko might have to answer. It's one is how many students start at Eastern and transfer into the OHSU program and or the ag program at OSU? We have a ballpark
Yes.
on that.
Yeah, I do. So Oregon State, the ag program, they're graduating in any given year anywhere between 25 to 40, maybe 45 students. And so if you think about the number of, 4 years worth of students, you can get an idea of the magnitude of that program on campus. It's definitely one that we want to grow and help them grow. But we're also pushing into that territory with a ag entrepreneurship degree that our board just approved this last week. But that'll work in partnership with Oregon State as well. And then Oregon Health Sciences University nursing program, a couple things to mention there. One, in terms of their program, which is, it's not just at EOU, they also have one down at Oregon Tech. And then at their main campus in Portland, our test scores are consistently some of the highest of all students. So it's hard to get into EOU's OHSU nursing program. It's a great program. They're having cohorts between 25 to 30, graduating slightly less than that in any given year. And the distinction about the OHSU program relative to OSU's ag program is if you're in the OSU program, you're part of EOU, you kind of go through the whole system with us. OHSU, you don't have to be an EOU undergrad to get into the nursing program. Obviously, if you are part of our undergrad system, you kind of have a leg up, but you can come from another institution and get into this nursing program. So it's very competitive. And one of the things we've been looking at is other pathways for those students to take if they don't get in to our nursing program, so that we can continue to help them fulfill what their dreams are through their experience at Eastern versus having to go somewhere else.
To get my mute button corrected. Thanks, Tom. Appreciate it. And those partnerships have been around for quite a long time. It's they've been decades, literally, correct?
That is correct, yes.
So I think, and I'm looking here in my camera, and I think I see, it looks like the chemistry chem club may be ready to go. I think I even see a special guest down there, a big tall guy wearing a mask. And I'm going to, I think we can throw it, looks like they're getting ready actually almost. I think Tom wanted to thank you for spending some time with us tonight. You want to chat a little bit here?
Yeah, let me close out and then we'll actually get to the excitement. One thing I want to highlight, Badgley, the namesake of this building, really exemplifies what Eastern's about in terms of our faculty. Ralph Badgley had a tremendous impact on so many students back when he was faculty here at Eastern. He was a physics professor. And in fact, we've received some very large gifts as an institution because of the impact he had on students literally decades ago. And so his name really exemplifies what Eastern's about. And also what you've seen tonight are examples of what make EOU special and are unique to our mission. One, you saw some of the collaboration that occurs within this building, this structure, and it's not the only place that it happens, but ODFW, OSU, OHSU, we have regional solutions here, and it's opportunities for us to fulfill our mission relative to the community and being very interconnected with our community and having experiences for our students with these organizations is important. And then I would simply close with what we're really committed to at Eastern, and hopefully you got a feel for this just hearing some of our faculty, and then you'll see some of our students, is we're committed to graduating students that go on to live a great life and have a fulfilling career. And what I'm proud of at this university and thankful as an alum and actually as a father of a student now that's studying in the sciences is Eastern offers what I would consider an elite private school experience that's accessible to everyone. And that's special, that is unique across the nation, and it's because of the people that have come before us and those that are here now, faculty, staff, and alumni that allow us to do this. And so I just want to thank all of those that contribute to making Eastern such a success with the primary mission of serving students. So with that, Tim, I'll turn it back to you.
Thanks, and thanks everybody for being here. We got one more treat in store for you from the Chemistry Club. First, though, click on the feedback survey linked in the chat box and tell us what you want to see next time. We'll also email this out to everyone who is attending tonight. And don't forget to stay connected with EOU on social media. You can find us or check out our wherever we're at on social media, or check out our homepage, eou.edu, to click on those links. Now it looks like Emma and her Chem Club pals have something special set up in the lab.
That's right, Tim. I'm here on the 3rd floor of Badgley Hall in the chemistry lab with Monty and the president of the EOU Chemistry Club, Brady Lehman, and a very special honorary club member. Chem Club has earned an outstanding award from the American Chemical Society for 11 years running. Part of the reason they earn these awards is for stellar outreach. EOU students in the club visit schools and put on chemistry magic shows to get kids excited about science. He's got an experiment all set up for us.
Hi everyone, my name is Brady. I'm the president of the EOU Chemistry Club, and today I have a very special lab partner. So we have 4 different experiments for you all today, and first off, we're going to start with making some simple Kool-Aid. So I'm a junior in biochemistry here, and so I should be able to mix some Kool-Aid together. So let me try to mix this together here. And as you can see, it's not working very well here. And so I can try and put a little, to try and color it a little bit, I can put some coloring in and it works out better here. And now Monty, do you want to try and mix some more Kool-Aid? And so Monty can make some more Kool-Aid. And what I can do is I can actually do something pretty neat to this. Is I can make it turn lighter color here. And so very gradually, I'll actually speed this up a little bit, is I can make it go clear. Which is crazy, right? Kool-Aid shouldn't be able to do that. So there's actually this, as you might have guessed, this isn't Kool-Aid. We are dealing with an acid and a base here. So we use what I added the color to is phenolphthalein. And so phenolphthalein reacts with the base and forms a deep dark purple color or pink color, as you saw. But when I added the hydrochloric acid, it turned it back to clear. So this is one of the ways we can do different types of water testing, which is great. So there's lots of different color indicators, just like phenolphthalein, that react with a wide range of acids and bases. So next up will be Crystal, and we are going to do another experiment. So we've all been camping out here in Eastern Oregon, right? And we all love the outdoors. And just like normal campfire, we have some rocks around our campfire. And so when you're tired at the end of the day, you want to put out the campfire and go to bed. So that's what Crystal is going to do here. Oh, that's not working well, is it? It's crazy. The fire went out, but now the rocks are on fire. So unlike most magicians, we actually like to tell our secrets. So you might have guessed those aren't normal rocks. Normal rocks don't light on fire when they react to water. These are formed from calcium carbide, which is a really heavy oxidizer. So when it forms an oxidant, and so when it gets in contact with water, it'll actually ignite. So we have to be really careful in our chemical stock room to make sure it doesn't come in contact with water. So thank you, Crystal, for that. Next up is Dempsey, and she's going to be showing how fireworks work. So we all love the 4th of July. And with that, we get to see lots of different colors of fireworks. And so you might have always wondered how these work. And so we actually use salts in fireworks to make them colorful. So Dempsey's adding different salts right now that are reacting and emitting different energy photons. And so they're going up from their ground state into their excited states, essentially. And what you're witnessing right now is actually a portion of a general chemistry lab that we run here at EOU. And so this is a really good example of what we do here at EOU with our freshmen and teaching them about different types of chemistry. And so Dr. Heidemann actually designed this lab also. So as you can see, it creates a really fun color. I think Dempsey will now go on to iron, which I think we've all played with sparklers before, and some of you might have wondered how that works. And so we're going to examine that here. So as you can see, this reacts like a sparkler or a fountain you might see. And so the iron emits really high energy photons and it combusts. And so you get the sparkler effect. So now we're going to be moving on to something we call methane mop-up. And so while this might look scary at first, this is actually going to end up being perfectly safe. So Jonathan here is in trouble because he hasn't been studying correctly. And so as punishment, he is going to be our subject for this. So do we want to go again? Sure. And so as Jonathan will demonstrate here, methane actually burns at a fairly low temperature. And with Jonathan having dipped his hands in water, that allows a protective barrier to form around his hands. So we don't smell burnt hair, which is great, which means he properly coated his hands in water. So that concludes our couple demonstrations. We hope you enjoyed this short demo. These are just a couple of the activities that we bring to different schools around the northeastern Oregon area, into Idaho and Washington also. We have lots of more demonstrations that we didn't show here today that are more educational based that we also bring to national meetings. We submitted a chemistry demo that's currently under safety review, and that will be submitted to the national, that's already been submitted to this year's national meeting. So I want to thank you for supporting the EOU College of Science, the Chemistry Club, and the Chemistry Department as we continue to further our education in the chemical sciences. Thank you.
Wow, science is so cool. Signing off from Badgley. Back to you, Tim.
Thanks, Emma. And I'm glad nobody got hurt during the experiments. It's always good to see fire being played with in a responsible manner. Please let us know, everyone, on how things went, and watch your email for an invitation to the next Eastern update. Good night and go Mountaineers.